Let's briefly analyze the stress strain graph for different types of material. Okay, so here different materials would have different shapes for their stress strain graph. So I'm going to pop up a graph over here, so to let you roughly see what are the shapes for a stress strain graph for different materials. Okay, so you have your stress as your y-axis and your strain as your x-axis, and you can see that these are the stress strain graph, how it looks like for steel, glass, copper, aluminium, and bone. Okay, over here I hope that you're able to notice that there's two general shapes for stress strain graph. One is the shape where you only have a straight line, then that's it. Okay, it's material like glass and bone, you can apply a stress towards this kind of material and you undergo strain, but the stress and strain are proportional to each other till the point where the glass breaks or the bone fractures. Okay, the stress is always proportional to the strain throughout the process until it fractures. So it also means that there is no plastic deformation that happens to this kind of material such as glass and bone. So if an object or if a material experiences little to no plastic deformation before fracture, we call this kind of material as being brittle. Okay, so brittle materials experience little to no plastic deformation before fracture. This is what we learn when we talk about brittle, ductile, and malleability. Okay, next we look at steel, copper, and aluminium. The stress strain curve for these three materials, you can see that besides having this linearly proportional region, you also see some curve at the later section of the curve. Okay, at the later section of the curve, you can see there's non-linear sections already. So these non-linear sections here, most of these sections are actually plastic deformation. Okay, so that it means that it starts with elastic deformation or deformation that are not permanent. Then after that, it will enter a region where it will be permanent deformation or plastic deformation. Okay, so you see that steel undergoes a great amount of plastic deformation before it breaks. Copper, this starts out with elastic deformation or non-permanent deformation, but after that it enters a long region of plastic deformation, only it fractures. Same for aluminium, start with elastic deformation or non-permanent deformation, but after that also a great deal of plastic deformation before it fractures. So if these materials undergoes a great deal of plastic deformation before it fractures, we mentioned earlier that these kind of materials are called ductile materials because they experience significant plastic deformation before fracture. Okay, in the next video, we'll be first discussing the stress strain curve in greater detail for brittle materials. Then we have another video which explains the stress strain curve for ductile materials as well.